Now let's return back to this question. We're going to do learning objective B, which is simplify rational expressions with binomials or trinomials. Now again, this here on the top is one complete term. It's x plus 5. That is a binomial. This bottom one is an x. You cannot come in here and subtract out and cross off the x's. You're going to want to do this. You're going to want to say these x's cancel. Let me show you why that doesn't work. What if we put the number 3 in for x and we kept it like this problem here? That'd be 3 plus 5 divided by 3. If you simplify, it'd be 8 divided by 3. And this becomes in my calculator 2.67. Now, what if we said, wait a second, let's cross off the x's. And if I had x equal 3, there'd be no place to put them. So if x equaled 3, the answer would be 5, which doesn't make sense. You can't actually do that. What you have to do now in Chapter 9 is look at the groups. You can only cross off the entire group if the entire group matches. So for this problem, if we have one group of x plus 5 and it's divided by another group of x, they have to look identical. So in order to want to cross off this group of x plus 5, I need another group on the bottom that looks just like that, that says x plus 5. There is not one, so for this problem, there's absolutely nothing I can do. I make no changes, and that is my final answer. So let's look at number 3 here. This is, again, here's a monomial, that's a binomial. So I can only cross off an x plus anything in that x plus 1 group if I see another group on the top that said x plus 1. There isn't, so this group must stay. However, I can look at this. This is a normal thing from Chapter 6. I can't get rid of this single x right there, but I can simplify the 9/12. I can pull a 3 out of each. 9 divided by 3 is 3. 12 divided by 3 is 4. So the only thing I can do is rewrite that as a 3. That x on the top stays. Change the 12 to a 4, and the group x plus 1 stays. Again, you cannot cancel these two out because this group is a single x and this entire group is an x plus 1. They have to match perfectly to do that, and they're not. So that's the final answer. So let's look at some more of these that have a little more work. Number 5, this top one is a binomial. So I'm looking for a group that looks like 2x plus 1. This bottom group is 2x. I can only cross them out. For example, if they were both 2x plus 1 over 2x plus 1, great. Then I would cross that out and cross it out because they match. But they don't. Can you pull anything out of this top group, like a 2 or an x? You can't, so that's actually not going to help you. That ends up being the final answer. Number 6, though, again, we have this one monomial, another one, and we have this binomial group. So if you don't see another x plus 1 group, you can't touch it, just leave it there. So all that we can look at is this left over. Can you cross anything off? Sure. The 3's get crossed off, 3 and 3. I have x squared on the top and x on the bottom. You can subtract those, 2 minus 1. Or get rid of this 1x, because that's a single x and this is 2. You can get rid of this 1x, and you can get rid of one of these, so you're just left with x to the first. So our answer is going to be a 1x, x plus 1, all over 1. We typically wouldn't put it over 1 like this. We would get rid of that, nor would we really write this 1. So our final answer would just be x and x plus 1. And that's considered simplified. Now this one gets a little more involved. The group at the top is a 2x squared plus 8x. The group on the bottom is a 12x. Clearly these are not identical. You can't cross them off. However, on the top you have to think about, can you pull anything out of this group that they have in common? You can pull out a 2, and it looks like you can pull out 1x. If you pull out this 2, 2 divided by 2 is 1. If I pull out an x, I'm left with an x. So I pull a 2 out of the 8, 8 divided by 2 is 4. If I pull out this x, it's just gone. Now on the bottom, I still have 12x. Again, I see no other groups of x plus 4, so that stays. However, I notice these two x's can cancel out. I also realize I can simplify this 2 over 12. I can pull a 2 out. 2 divided by 2 is 1. 12 divided by 2 is 6. So what I'm left with at the top is a 1, x plus 4, on the bottom a 6. Again, I typically won't write that 1, so the answer is x plus 4 divided by 6. Now these next two are going to challenge us to do some factoring. Again, number 34, it's very clear. X squared minus 4 and x plus 2 are not identical groups. However, we have to remember factoring. X squared minus 4 can be factored. What that is, I can factor it into two groups. If you look at it, remember we could do this. We could say x squared plus 0x, because there is no middle term, minus 4. To factor that, I take the first term in there and I split it up equally here and here. I take the last term here and I put it in the last parts of these two binomials here and here. And I'm trying to find the right combination such that these two, when they multiply together and are added, you get 0. So to start with it, to break up x squared, my only choice is x and x. To find factors of negative 4, I could do 4 and 1 or 2 and 2. To get negative 4, though, I'd have to do negative 2 and 2, possibly. So let me try negative 2 and plus 2, because negative 2 times positive 2 is negative 4. Now when I multiply here, I get negative 2x. When I multiply here, I get positive 2x. Notice these two values, when you add them together, are 0. So this top I just factored. So the top now is x minus 2, x plus 2, all divided the group on the bottom of x plus 2. Now here's where this gets neat. Notice there's a group that matches. That x plus 2 and that x plus 2 gets canceled out. So our final answer here is going to be the one binomial that's left, which is x minus 2. And that's our answer. Now on 35, again, it's clear that this top group here, which is a trinomial, clearly does not match the bottom one. So they can't be crossed off, but both the top and the bottom can be factored. Now to factor the top, we're going to, again, take the x squared, and it goes here and here. The only option for x squared is x and x. I have to think of factors of 18, such that they go here and here. To get 18 would be 18 and 1, 6 and 3, 9 and 2. We need to find the combination that when we multiply this and add it together, we get 9x. So the two numbers that multiply to positive 18 would be plus 6 times positive 3. And when you test this out, you get a 6x and a 3x, which add to 9x, so that's properly done. Now to factor on the bottom, the only other thing you can do here is you can pull out a 4 from each thing. So let me just rewrite this so it's nice and clean. I'm going to show the clean factoring at the top, x plus 6 and x plus 3. Now to factor this bottom, you can factor out a 4. So I'm going to pull the 4 out. 4 divided by 4 is 1x. 24 divided by 4 is 6. Now you can hopefully see there's an obvious group. X plus 6 can cross out. So with that, what we're left with on the top is x plus 3, and on the bottom is a 4. No other groups match, so that's our final answer.